So as you know, this week we're working on problem decomposition, and that is the idea of taking some big task and breaking it down into a bunch of manageable pieces. And last time we looked at a piece of software totally on the computer and how I broke down that task into a bunch of pieces. But today we're going to take a look at something on the microbit. And so I know some of you have worked with microbits before, but this is an entire computer built into a little board, and you can power it by a USB cable, and it has all sorts of interesting things built into it. It has buttons, it has lights, it has acceleration sensors, it has a thermometer, it has a whole bunch of stuff. And so devices like this make it really easy to build solutions to problems that are around. And so I want to show you an example of this. So let's take a look at the overhead camera, and I'll take a look at something that I put together using the microbit. So here's the idea. During lockdown, eggs have been really hard to find, and I of course don't want any broken eggs. And so my thought was, if I could build a device that I could put into a container that could detect if the eggs are being shaken around too much or shocked when they go over a big bump, that maybe I could hold the shipper responsible for that, because I would get some kind of feedback on the microbit showing that had happened. So maybe the place where the eggs are collected or sold, you throw one of these in, it has a happy face, you put it in with the eggs. If it arrives and it has a happy face, you know that the driver did their best to try to keep it from jostling around too much. But if there's too much shaking, this will show a frowny face. And so that's what we're going to be looking at today. I am calling this project the shock detector. So this is a really big problem, and there's a lot to go on in order to make this work. So before we get into it, I want to talk about some of the distinctions between the hardware and the software. So the hardware is anything that is physically built into this device that is going to help us solve this task. So that's the sensors, that's these buttons, it's the physical parts of this tool that we're going to be using to solve the problem. The other piece is software. There's going to be elements of this where we use what the hardware tells the program to do something in software that's going to help solve the problem. It can be really useful to switch back and forth and say, is this something that the hardware can solve, or is this something that we can write software to solve? And sometimes the answer is a combination of the two. Let's take a look at how this might break down in the microbit programming environment. This is MakeCode. This is the editor that we're going to be using to experiment with this, and it allows you to simulate a complete microbit all in the web browser. So it's really, really cool. And so let's start breaking this down. I know that I'm going to have a step where I need to find out the acceleration. Presumably that's just going to be asking this, what acceleration are you reading right now? I'm going to need to compare that to some maximum acceleration that I know is going to represent like a shock, something that could break the eggs. So I need to compare that value to that maximum. And so thinking about it a little more, I know that if the acceleration is more than some critical amount, I know that I'm going to want to show the sad face instead of the happy face, because normally the happy face is what shows on the microbit. And just for the purpose of debugging, I may also want to show what that acceleration is and what's going on in the system, because that kind of feedback really helps me in understanding if I'm headed in the right direction. Now there's one more thing that I'm thinking about as I'm doing this. I may want the ability to reset my system. So suppose that I've seen the unhappy face. I don't want to now have to throw away the microbit. I want to be able to reset it. So I also want coding here that's going to make it so that when maybe I hit the button and hold it and release it, that resets the system so that I have the happy face and I can use this device again. So I've now identified some specific tasks, 5 things that I need to include in my program, but I think I can do even better, because some of these steps I may want to break down further. For example, find out the acceleration. There's there's some complexity here because the acceleration on here isn't read in meters per second squared. It's actually read as a number between 0 and 1023. So just that step of finding out the acceleration is going to have a few more things within it. So let me see if I can break that down a bit. So I think this will get us in the right direction and convert that sensor value, so from a number from 0 to 1023 over to acceleration. Now, I want to stop for a minute because I would not expect you to come up with all of this right now because you don't know as much about this and what it can do as I do. So I'm just modeling the process that I go through when I'm thinking about this before I even start coding. I think about what are all of the things that my code is going to need to do so that I have some very clear tasks that I can undertake to get this programming off the ground. So I'm going to do some work on these. I'll get back to you in just a minute as I play with this. Okay, so here we are. This is what I've laid out as all the different steps for what I need to do. Again, I haven't coded anything yet. We're still in the phase of trying to figure out exactly all of these things and what we need to do. Now that I have a good idea of all the things that I want to do, I need some help. Weinberg here. Hey, are you there? Yeah, everything okay? Yeah, I'm here with the class. I've just put together a bunch of descriptions of what I need functions to do. So it's kind of like the algorithm, it's kind of the output. I was wondering if you would be able to maybe write some of this code for me. Do you have the details of what you want the code to do? Oh, you want me to write the function descriptions? Inputs, outputs, you know, that kind of stuff. Yeah, you're right, that would be really helpful. Okay, so what I will do is I will write some functions and I'll define the inputs, the outputs, and maybe some algorithms that you can then use in putting those together. Perfect, that sounds great. Perfect. All right, I'll send those right away. Love you. Love you too. Bye-bye. Okay, well, I have some work to do. So in the next video, I'm going to show you what that document is, and I'll be able to put that together. And you and I can then get started in implementing some of that into the code. So I'll see you in the next video.